All right, we're back. We are MAPD714, and it's the fall 2017 semester. It's week 11, part 3. We're supposed to be talking about collection views, but we ran some other things we're talking about. Okay, so check this out. This is new. This is new. All right. All right, so I ran some problems with my test. It did everything I wanted to do. Guys? Sorry, we're continuing now, right? So we ran some problems, right? We had our deck and we passed it this stuff, right? And when I did my test, I got some weird numbers. Okay, well, yeah, of course I'm going to get weird numbers because my hash value, I did something like this, my hash value. Okay, what's the hash value? It's got to be unique. It's a unique value, right? That's what it is. A unique value that I'm passing into this thing. Each hash value for a set, each member of the set must be unique somehow, right? Does that make sense? So what I'm trying to do is actually create a new ID, if you will. Think about this as each set member has its own ID, right? That's what it's like. And I'm not giving it its own ID. I'm giving the same value. And so what's happening is each set member is being overwritten. And that's why I'm only getting 35 unique values, because what it's doing is it's taking off, it's taking my suit, I'm passing in my suit, and it's not getting the right value. So an example would be this. Okay, so here's I did this, hash value is equal to self.suit, and I set up a hash value of integer, so I can compare one to the other. That's what this does. If I want to insert, I can do that kind of stuff inside of my my card on my deck, right? So if I sort, I can do that kind of stuff. Okay, but let's take a look what it does. What it actually does is if I look through my my deck, I have this thing here, where I initialize. This works. It actually does return it. How I fixed it was, instead of me passing in a value inside my initialize method, what I'm actually doing is instead returning a value. Okay, hear me out. So I return a value. So I return the deck that I generate. I generate a new deck, and I return it back out again. That's how I initialize, right? And this is for all sets, unfortunately. And then what I'm doing is I'm printing out each of the suits, right? And each of the faces that I put into my card for testing. I'm going to take these print statements out later, okay? That's what this does. Okay, cool. And then I created another little function called display, like a toString function, okay? And what it does, it runs through the entire list to see what I have afterwards, okay? Just as an example, well, here's what I got. If I run it, if I go to my test again, and if I run this test, right now, the way it stands is I get build failed. I got 40 out of 52. It's a weird number, and it always changes, okay? It's not the same all the time. Sometimes it's 35, sometimes it's something else. Why am I getting that? Because my ID is not unique, right? I'm passing in the hash value is not unique, so it's overwriting the previous value, right? That's what it's doing. So if you look at this thing, right? Here's what I'm doing. Here's me initializing. I initialize, I have my diamonds. Here's where it's loading. Ace, deuce, 3, 4, counts all the way, goes to the next suit, counts. Here's the next suit, counts. Here's the next suit, counts. And then when I get to actually me trying it, it starts like this. The 13 of 2. 13 means king of the the third suit. That's what it is, right? The 13 of 2. Okay, and so on, right? And it keeps looping through all this stuff. It keeps looping through, tick, 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 like this, until it gets to, right? Notice that it loops weird, right? It goes the 1 of 0, the 2 of 0, the 3 of 0, and then the 1 of 1, 2, 5, 6, 7, but it skips some. It doesn't do them all, right? The 1 of 2, look, here's the 2s. The 2s, it almost got everything. So here's all the 2s, right? And it only got 1 of the 3s. Here's the 3. Why did it do that? Because what's happened is it's the exact same value. The hash value is the same. So it's like, wait a minute, you're overwriting what you already have, So it replaces when I add in. That's the way the sets work in Swift, right? So maybe sets are not the right type that we want to use at all. Maybe we want to use something else, right? Like a generic array of something else, array of card, right? And that's simple to test because we just have to go through here and go do something like this. If I go back to my my card, right, and where I say, well, here's my card, it's hashable right now. I could take away the hash value to check this out because I don't have to do this. And if I go to, you know, if I want to check it, if I want to check this thing as a set instead of a set of card, can I do something like this? Can I say it is of type? I'm just going to do it here in the open. If I wanted to do something like, let's say, make my little class, use my test class, right? Test, right? Just for a second, just to have a container for myself to work within, right? And if I did something like this, my deck is equal to an array of type. Can I do that? An array of type card, right? Can I do that? And yeah, the answer is I can, which is what I'm used to, right? In this kind of scenario. And if that's the case, can I do deck dot and have some kind of other things you can do with an array? Well, no, you can't, right? So the array allows me to do this. So it sets up a special type of array, right? But it doesn't give me any power, like I said, like the set would do, right? Like a deck dot something or another, right? Because it doesn't know what to do here, right? So here's my var. If I build it, right, it initializes, it builds, no problem. But when I do deck dot, it doesn't give me any kind of code hinting whatsoever. I can't do an append. You know, I can't do anything. Like if I press Control Space, and if I say append at the end of the deck something, you know, like let's say as an example, I can't do anything. I can't say, well, it's a special card of type. Let's just do one of these. And instead of suit raw value, I'll put in like the suit is 0. I think I start at 0, and the face raw value is 1, right? I don't think I can do that, right? To append to an array. I don't think so. Sometimes it's not giving me a thing because it says expected declaration, right? See that? Doesn't really figure this out. It doesn't know what to do, right? How about a dictionary though? So if I go var, you know, and I want to make a dictionary of type, so I call deck, which is equal to a dictionary, right? And now in my dictionary, I have key value pairs, and my key. And again, if you think about what a dictionary will allow me to do, right, when it comes down to it, when I declare a dictionary, I want, you know, the key and the value. The key could be a string. Typically, it is. But typically what we do is some kind of string and then integer. That's what I want to make. So the deck is a string integer kind of dictionary, right? And then, or I can make it integer, which is what I wanted. Integer, right? I could do that kind of thing as well, right? But, oh yeah, sorry, I have to make the open close things, right? I could do it this way as well. This could be the deck as well, a dictionary type. Okay, and then therefore I could have the suit and the face on this side as well. Now with a dictionary, I could do a deck dot, and then some kind of append or whatever. I'm just not getting any code hinting whatsoever. That's the problem. I'm not getting code hinting because I'm inside this class, and it's I'm doing two things here at the same time, right? But I should be able to do that in my test case. Let me go to my test case and try that out. So if I went to my test case, let's make another test case altogether. Test dictionary. And if I did that, if I said that my deck is actually a dictionary of type int, then I should be able to get some code hinting. Yeah, I thought so. I should be able to get my code hinting, like my count. I should be able to do other things. I can't do a shuffle. It's still not available. I can do other things, but this totally works okay. A dictionary of int, right? But then where's my card? Right? It's not a dictionary of cards anymore, right? That's weird. right? That's the problem that I have. And what I really would want in this scenario is for deck is an array. Sorry, I just didn't get code hinting before. Deck is an array, right, of type card, right? That's what I really want, right? Where a deck can do this stuff, an append or an insert or all that kind of stuff. That works fine too. And so maybe, you know, what we want to try and do is this instead of, you know, other things, right? Because what can I do with arrays? I can insert, I can append, I can't delete. Maybe I can remove, right? Here's my remove, and I can insert, right? So this is the thing I can do. I can insert or whatever. I can't pop, or I can pop last. That takes away the last one. I can't push because it's not that kind of, it's not a stack like that kind of thing. But those are the things that I can do with my deck, an array of cards as opposed to a set of cards. Well, if that's the case, let's try retrofitting it so it'll be an array of cards instead. So instead of a list of type card, let's just change this up really quickly. I'll say array of type card. So now instead of a set, we'll just change set to array, right? And we can test this out. We can test all these out because let card, this still works. And if I do this, right, that still works, right? So array of this thing works out. Test succeeded. I can test each individual one. Now remember that also one thing you may want to try and do is do a couple of things. One, clean. I want to clean my stuff, as well as I want to rebuild what I'm doing here. Now instead of set, I want to add it to array. So all arrays have this functionality. It's the same thing. I'm just adding my, I'm doing an array of type card as opposed to a set of type card. And it's the exact same thing. That shouldn't affect anything, in fact. Now, the only thing is it doesn't tell me where to put it, right? Because one thing with the array, which is different than I want to append, not insert, right? Because append actually adds it to the end, right? It does. So that's what I really want. I want to append this to the array. And then I want to print the array. That's what this does for every card in the array. So this isn't going to change much. So I've saved that part. The suits and this stuff, I got to think more clearly about this. I'm starting at 0, 1, 2, 3. Yeah, okay. We may want not to do this anymore. We'll see. And this is pretty cool. I'm just showing you these structures so you know how to use them in case you want to, because they make it more convenient. That's what they are. They're really convenience more than anything else. Okay, good. So here's my test struct. Instead of text struct, it's going to be test array, card array. It exists. I'm just going to rename these things so that they work properly. So face, here's my card. I'm going to check that they're equal by raw value, right? This works out an array of card. This works out an array of card, right? Test initialize method. I'm going to initialize. And it says value of type card has no member initialize. Okay, yeah, you're right, because it's an array of card. An array of card, right? And that should work, but it's giving me a problem. Initialize. Oh yeah, maybe that's not working because I have to repopulate everything. It did. That worked. And now it's the same thing. I can't do that. It's got to be an array. I'm almost there, guys. I swear. But I wanted to show you my problem because it's just a problem in thinking more than anything else, right? That was the problem. It wasn't a problem in execution necessarily. It was a problem in thinking. My thinking was totally wrong for this thing, and that's okay. Having it wrong, I'm happy with having it wrong. This is what the whole reason why we do this stuff is, right? And now everything passes. Okay, so if I look at that, if I go back to this, I can see now that I'm getting this. Here's all my initialization, and then these are the values: 1 of 0, 2 of 0, 3 of 0, 4 of 0, and it goes all the way till 3. So there's 52 cards now. Does that make sense? Test-driven development, really. And I did it kind of without totally planning it all out, but I think we accomplished a really cool thing here, which is really understanding how things work. And at the same time, we learn about enumerations, a little bit about sets, a little bit about dictionaries, a little bit about arrays, a little bit more about arrays. One thing that I probably would do differently in my print statement, right? Notice how when I do my suit in my deck, here's my deck. So I'll go back to the deck and I'll go to one of these. So here's deck. Notice how it says suit and then suit as I loop through, right? So I have my suit and then my deck. And then what it's doing is I'm actually getting the face and the suit, right? That's what this is doing, face and suit. And I'm only looping through the deck one time. Well, really what I want to do is maybe, can I print out the card? Can I send the card itself to print? Does it have a conversion for an array to string, right? Like, for example, I'm doing the face of whatever, right? Here's the card face and the card suit, right? And what I really want to do here is I want to cast it as an enumeration, right? I want to say that is of type face. That's what it is. And I want to do as suit. I think if that might work, that might give me the actual value that I want, and it can't convert, of course. To typeface, yeah. Because what I'm doing is I'm actually getting the raw value, and that's not what I want. I want the actual enumeration value back, right? That's what I want. Again, going back to it, you can make an enumeration of type strings as opposed to of type, integers and so on. And so, this will be a little bit different. But the idea that we made, it works okay, right? All right, so I'm going to put this up on GitHub so you can see what I did here just to talk about this stuff. Let me just fix this up. So you can understand a little bit of test-driven development. There's more we're going to do. This is just the beginning, almost like scratching the surface. I really wanted to kind of talk about it. So you've had it. That was one of the things I wanted to do today because we were running a little bit shy this semester. Okay, that's cool. And now for my for GitHub, what I want to do is I want to add a remote. So I want to create a new remote up on here on Centennial, right? It's going to be public, and I'm going to call it Lesson 11A. Okay, that's going to be created. That's one thing I really love about the new Xcode. It's really cool. I like that part. I'm also going to do a commit. I made all these changes, and I'll say test project, really, or project to showcase test-driven development. That's what I really want to do. So commit 7 files. And then I'm going to go back to push. And then that will be up on GitHub for you guys to check out later on. Okay? Okay. Any questions around the stuff we did? We did a lot of little things, right? So we went around in circles a little bit. But the good thing is that we kind of hashed out what to do with structs. So you guys should understand the difference between structs and classes, more or less. I really wanted to kind of hammer the point that we could have some small structure as opposed to a big class with methods and extension methods, how to do those with basic structures that exist. Okay, so let's get rid of this. I'm going to start a new Xcode project now, and it's going to be the new one. This is going to be it's a brand new Xcode project we're going to do for the last part with a single view app. I'm going to make it called MAPD714-F2017, and it's going to be a lesson 11B. I'm not going to do a unit test this time around, just to simplify. Next time, though, next week, please expect that I will do unit tests for everything, right? We'll just make it a little easier. Okay, then click next. Okay, cool. Yes, I do want to get repository. Click yes, create. And now I want to talk about this collection stuff that we've done before. So we've done table views before. The problem with it is that they're limited cells. And if you follow the PowerPoint, what we're doing today is making our own custom cell, What the PowerPoint really does is it says, look, we want to make a cell that has something like this, where you have a header and you have a description, right? And here's almost like a chat. Think about it this way. You have the first witch, right? And the second witch and the third witch. They're all witches talking to each other. I don't know. 3 witches, where they're going to meet. And it's like you have the header is the name of the witch, and then there's some kind of words on the bottom, right? Now, this is really quite difficult to do because in a typical cell, you don't have this structure as easily, right? And especially with the spacing and everything else they add in here. And this is what this whole lesson is about. And that's why I didn't really concentrate too much on it. I wanted to do the other stuff first and then go back to this, right? But this is neat. And there's a couple things, couple structures here that I want to talk about really quickly. So to set up a project, what I want to do is in my main storyboard, I want to kill this main storyboard, this one. And so let's just kill this view controller completely. So just press delete. Right, so there's no main storyboard. And in my view controller.swift, we want to change what this thing is inheriting from. So instead of UI view controller, it's going to be a different type. And it's really going to be this UI collection view controller. And the collection view is really the ability for us to make our own custom cells. That's what it allows us to do, right? Now they call it a dialog viewer. We're not going to do that. We're going to make it something else. So UI collection view controller is what we're going to make. So going back to Swift, UI collection view controller, right? That's what this is. We can get rid of did receive memory warning. We don't need that right now. This is going to be pretty full, this function, in a second, right? Oops. And we're going to drag and drop a collection view controller into the main storyboard. So in our main storyboard, I'm going to shop for collection view controller. Right, there it is. So I'm going to pull that back in. Here's my collection view controller. Okay, and notice that this, in part of this, I have this nested collection view right here with a collection view cell. And I just want to get rid of it. So just get rid of it. So delete. And in fact, if I delete this too, right, can I delete that? Yep, I can. I have this, an empty controller. Okay. Now that's what it tells us to do. If you look through here, it says, hey, go through and you see this nested collection view and get rid of it. Right? That's what it tells you to do. And actually, we deleted the wrong thing. It's called collection view cell. Let's just undo that. That's a good thing about things. So we want to get rid of the cell. This part, that's the cell we want to get rid of, not the collection view itself. Okay, good. So we got rid of this. Great. And now we've got to do some work here. If I click on this view controller, you can see that if I go here, I want to specify that it's the view controller like we did before. And inside here, we want to specify that it's the initial view controller. So it knows where to start. Stuff we've done before. Okay. And then what it does is if you follow your PowerPoint is it really talks about adding in this cell class. And we're going to make 2 subclasses. One, we're going to make this cell class called content cell. And then we're going to subclass this content cell into a header cell. So the header cell is going to be, it's almost like a, an extension of the content cell because it's going to be a header, not just content. Okay. And this is the first part. So we're going to declare this cell as a new Cocoa Touch class that's going to inherit from UI collection view cell. Okay. So we're going to go back to here. We're going to add in a new item, right? New file, which is a new Cocoa Touch class. Next. And we're going to call this content cell. Be careful what it does here because if you type in UI collection view cell, then it changes the name of your class too. Be careful. This name of the class. You don't want this. You want this. You don't want a nib. We want it in Swift, and we want to click next. All right, so it does this, and we don't need this stuff for now because we're going to get rid of it. We do have this UI collection view cell part right here, right? And if you notice, the first part is we need a label, a text, and a max width, which is a CG float, right? A label would be a UI label, right? So we want a label right? Which is of type UI label, right? We want text, which is a string. And we want a width. Is it max width or width? Max width, right? Which is of type CG float. What is a CG float? It's a float. But it's specific for computer graphics, so it has a specific type. UI label. Did I not do this right? Oh, var. Yeah, var would be good. Okay, there we go. That's your beginnings of the UI collection view cell. And then we have this custom thing. Now take a look at this. Again, remember we talked about new things today. Here's something new. Look, it has the class keyword inside the class. What does that mean? Anyone know? Anyone guess? If you're an object-oriented programming, it means something else. Not a subclass. It's not a subclass. So whenever we have this function, I want you to think about it as a class function. It's like it's a required function more than anything else. So when I subclass, it'll pass down into as a required function. Now there's different keywords you can use here. Okay, we're going to also see the required keyword in a second. Okay, but this class function is almost like it's not a static function, but it's part of the class itself, right? So it's almost like a special type of method, right? And it's going to be something that's going to be required by subclasses when we're subclassing. So class func size for content string. So we're going to say we're going to do that. So class func size for content string, right? Size for content string. It's our own class, which is of type string, and we're going to pass in for max width, right? Max width. That's just a descriptor, right? And of type CG float. And that is that part. It's also going to return an object of CG size. Okay, so that's our object. That's our new method that we're adding in, right? And we're missing a return because all of these need a return, which is CG size 0. So return CG size dot 0. Guess what that means? 0.0. That's what that is. It's a really cool thing. Why would I rather type CG size 0 as opposed to CG size 0.0? It's more compatible, number one. I don't know it might be different on different devices. And that's what this does. When I use a type like this, CG float might work differently on an iPad or future iPad than it does on an iPhone, right? So from a compatibility perspective, instead of me putting an actual value in there, I'm putting a type, right? And not float or double or one of those, but a CG float. And for those people anyone who's ever done computer graphics, we have other libraries like that too. There's one called Glue, right, in computer graphics. And what happens is, because different machine architectures have different sizes for bytes, or different sizes for floats or doubles or whatever, the size of the actual data type, we use standard size like this that convert the type for different device architecture, right? For here, it might just be a convenience thing that Swift does for you, right? Okay, so this is the first part. And then we have this other part where we have the initializers. So we have two things, right? Because what we're going to do is we're going to change our type, right? Because it's a UI collection view cell, it has a couple of optional initializers. One is an it frame, and the other one is an it coder. And you have to do both if you do one. If you do one, you have to do both. Notice the required keyword, right? The required keyword is there because its superclass has the required keyword. Once you use required, it's always required. All right? And what it means is you must have that initializer. There's no option not to include it. And sometimes we do that when we build up classes because we want to make sure something happens in a certain way because maybe you need the initializer for some reason. Okay? So here's my override init frame and override this required init coder. Okay, so let's do that. So override, right, init, and then frame. And notice once I do this, right, it says I need the initializer coder right away, right? And I can just fix it by putting in, notice it puts the required in there right away. Okay. So here's the frame and here's the coder, and we're going to return, obviously for this one, it's just one return statement, which is actually it's going to be we're going to initialize the super class with the coder, which is of type 8, the same type. So super dot init, and it's a coder, right? Just the same thing, which is of a decoder. And what this does is it sends off this default value, to basically, it's an NS coder. NS coder is a special type. And what it does is it almost creates a hash value for my content cell. It's exactly what we ran into with our set, right? This creates the UID, UUID, if you will, for different, some of them have UUIDs. This is the way it's done. Okay, now here for this particular part, this frame, what I want to do is it's a CG rect, and I'm going to send it to the super class first. So super.init. And then what I want to do is set up frame. I'm going to send off the frame that I got from which is of type CG rect. I'm sending it off to my super class as well. And then I'm going to start using the label that I declared earlier. So label is equal to this new UI label with a frame, which is the content view bounds, whatever the content view is. Remember, this is a cell. The whole frame is going to be the size of the cell that I'm putting in here. That's what this does, right? So again, I say label is a new UI label. And what we want to pass in is a frame, right? I'm typing it in, but you could also find it, which is self.contentView.bounds. Okay. So what I'm saying is, hey, make a new label and the same size as the bounds of my cell, whatever that is. Okay. And then I want to say is opaque. So label dot is opaque is equal to false. That means I can see through it. Right? Is opaque. Label background color is 0.9, 0.8, 0.9, 1, and 1. So label dot background color is equal to a UI color. UI color. And what I want is those three, red, green, and blue and alpha. That's what I really want right there. Okay. And if I do that, what I'm looking for is exactly this: red, green, blue, and alpha. So this is red, right? Green, blue, and alpha. And my red value is 0.8. My green value is 0.9. So what are these values? Why is it 0.9? What does that mean? They're normalized, right? They're normalized values from 0 to 255. They normalize. And normalizing means they change the numbers from 0 to 255 from 0 to 1, right? Where 1 is 255 and 0 is 0, right? So how do you figure that out? If I had some kind of hexadecimal value or some other kind of value, let's say I had a value of 89, I would take 89 divided by 255, and that would get my value, right? Whatever that value is out of 255. So example will be if I have 0.8, what does this mean in terms of red? Well, if I look at the calculator, just to remind you guys how this works, it's like 0.8 of 255, which means it's a value of 204 from a red perspective, right? If you know red, green, blue, out of 255, it's 204, right? And that's how it works. So it's normalized. And if I had this and I want to convert it to 0.8, I just divide this by 255 and I get 0.8. And that's what I put in here. These are normalized values. Okay, UI color, red, green, blue, background color. Did I do this right? Oh, background color, I'll be okay. Background color, right? Okay, there we go. And the next one is text color. Okay, this is interesting. So I'd say label dot text color. So I'm defining my custom cell, right? is equal to UI color, and I have a default black, right? By the way, here's a change. I don't have to put black in open bracket, close bracket. It's a property now. So that's different from this. It's not black with open bracket, close bracket. It's just black now. Yeah, this is Swift 4, right? So we have some differences between Swift 4 and Swift 3. All right. And yeah, label text alignment is center, right? So label dot text alignment, right, is equal to dot. This is like an enumeration, right? Look, there's the enumeration. NS text alignment, right? And then it's center. That's the enumeration, the enum, NS text alignment, right? And you can do that with our enumerations that we made today too. If I included the enumerations inside of my class, right, then I could say that, hey, whatever it is, dot center or dot, you know, whatever my suit is. Okay, cool. So I did this part. And then there's the font, all right? And notice I say label.font is UI font.preferred font for text style. Whoa, it's really big. Let's try this out. So label.font. Actually, just to make it so you can see it, I'm just going to scroll down. I'm just going to add some spaces so you can see this here, not because it's right. Label.font is equal to preferred font. That's what I want to do. UI font.preferred font. I'll be okay. UI font dot preferred font for text style, right? Which is this is an enumeration again. UI font text style dot body. UI font text style dot body, right? UI font text style. Okay, almost there. And then content view. Add subview label. Okay, we've never seen this before, I don't think. So content view, add subview label. Okay, so this is programmatically adding a label to the view. All right, as opposed to me dragging and dropping it from our library, this adds it programmatically, programmatic views for the first time, right? We haven't done this before exactly this way. Okay, so it generates the view, the label, as opposed to dragging and dropping it from my library, right? And we're going to see more of that in second semester when we create all our entire view by hand without dragging and dropping anything, right? It's a good thing to do, to learn, right? Because then you get more control, right? This is not so much control. Well, here we have to because we're building our custom cell, right? Now, there's other ways, actually. We could make a custom cell object totally separate and then take that other object and another storyboard, a separate storyboard, and bring that in. We could do it that way without doing this way, right? But sometimes it makes it more complex than this. This is very simple. This is like you make a label and add it in. We're just making a label by hand, okay? All right, and then we have this part we've done. So we've got this part. This is the next one, size for content string, right? So this is, we've done our initialization. Now we've gone back to this, size for content string. We don't want this to complain. That's why we did this, right? But now we're going to change size for content string to be this monster, right? Okay, so now we're going to go back to this. And we're going to say something like this. Let max size, right, is equal to CG size. Lots of typing, but I'll do it for you guys so you can see it. CG size. And in my CG size, I want to add a width, which is math width, and a height, which is 1,000. And let me talk about that in a second. Width is equal to max width. And size, CG size, is it size? Height, sorry, height, which is 1,000 units. Okay, what does that mean? So that's my the maximum size of my size for content string. All right. So what I mean by that is the content that I'm going to be putting in. So all what the witches say in her chat, 1,000 characters. That's what we're basically saying, right? So that's the height. Sorry, the height and the width. The height is this 1,000 lines. 1,000 lines. Pretty high. All right, and then options. That's what this is. They just called it ops. We're going to say NS string drawing options uses line fragment origin. Oh, This is, again, these are just settings. All right, so let ops, right, is equal to ns string. Whenever we see ns, right, is next step drawing options. And we can see that dot uses line fragment origin. All right, what does that mean? It means that one of our options that we're setting up is it uses the origin of the line fragment as the starting place to actually start typing the string out. That's what it does. Like very specific. Like where to start drawing your characters, where. Okay? And then the style is NS mutable paragraph style. That's a certain style. So let style is equal to NS mutable paragraph style. Okay, and then style line break mode is by character wrapping. Style.line break mode equals to NS line break mode by character wrapping. So it just tells you how to wrap the line. So what it does is it goes by character as opposed to by point, right? So it looks at the whole character when and it goes to the next line. That's how it wraps. Okay, and then attribute. This is a change. Take a look. See how this is like this? Well, because I had to change this because in the book it tells you something else, and that will not work. So I'm just going to copy paste here. Now, you won't be able to do that, I don't think, in the PowerPoint, but who knows? And let me talk about what these things are. So originally it wasn't like this. NS attribute string key, it was something else, right? And now we have two parts. There's a font and a paragraph style. This is a new structure that they put in Swift 4. Don't worry about this unresolved identifier default font. We're going to put that in later. Okay. All right, so this is the attributes. So we talked about the attributes. Here's the style. We don't have our default font yet, but we will. And now we have two more things. String is equal to S as NS string. I don't like that, but hey, that's just me. Let string is equal to S as NS string. Basically, what we can say is we can say S instead of string, and which I don't like. I think they could have used a different identifier here myself, right? And then let rect is equal to string.bounding rect, string.bounding rect. So let rect is equal to string.bounding rect with CG size. There we go. With the CG size being max size, ops, attributes, and nil. So max size, ops, attributes, and nil. And then, of course, we're not returning this anymore. I think we're returning rect.size. Yeah. All right, so what this does is it's the size for the content area, the size for the content string. It basically defines your size, how much is in the content string area that you're using, okay? Now, so what's the point of this PowerPoint this time around? That's why I kind of focused on the other stuff, not this stuff. It really talks about the complexity of making your own cell. Like this is remember I talked about, hey, we're not going to do our custom cell today. We're going to do it some other day because it requires a whole lecture, right? It requires its own concentration. And that's what this is. This is about, right? More than anything else. And we're going to do more of this in the following lectures. All right, cool. So we've done this. And we need this part. We need this this part here, which is default font. Remember I told you we need that? And that's going to go at the bottom of this thing, way at the bottom. We need this default font that I kind of added in, which is I'm returning UI font, preferred font for text style, which is a UI font text style body. So just a default font. And I think I have a default character somewhere in here. There we go. There we go. All right, cool. So that is your UI collection view, right? Woohoo, right? Crazy. And we're going to use this. Once we've got by this part, we're going to use this to create our other stuff. Okay. So that's it for this part, but we need the other part, which is our we need to change we need to create a getter and setter for this part here, because otherwise what ends up happening is when we get our label, we want to return the label from this option, from this content cell, and we want to be able to set the new text of the label as well. So I want to be able to set and get the label. Now I could do it by hand, but they wanted to have some special things when we set the label. And notice it just adds different properties to the label, and we're going to add that in now. So up in here, instead of having the label by itself like this in the text, this is where we start doing this extra stuff. And what you can do is you can add getters and setters, right? So when we get, here's the get part. When we get, we can return the label.text. That's what you want, label.text. Okay? Notice it's inside of this closure right here, right? So for this string, this is a property now. It's not just an instance variable. We're making it a property by using getters and setters. Here's the set, and we want to put in this new text value, new text. And inside the new text value, we're going to say that label.text is equal to new text. So label.text, which is expected, is equal to new text, whatever that new text is. But this is the great thing about setters, is not only can you set the value, but you can do other things. And people always question, like, why do you need getters and setters, right? We should never use getters and setters. Just use the direct value. Who cares if it breaks the OOP rules? Well, yeah, but you can do extra stuff, which you're going to see. So not only do we set the value, but we also do other things, like the label frame, right? Because the reason why we do this is because what if I'm creating the pixels in my phone, right? And it's got to adjust the size of the label, right? And the label keeps changing. So then I have to adjust my layout. So instead of adjust my layout, it does it right here. This is what adjusts the layout of my cell based on what I put into it, right? Okay, so let's try to type this in. I know that people are getting lost, but don't worry. I'm just trying to show you this thing. New label frame is equal to the label.frame, whatever that is, right? I'm getting the new label frame, and what I want to do with it, and also need a new content frame. So new, I think I called it, or a new content frame. New content frame is equal to label.content frame. Content view.frame. Content view.frame. Okay, and then the text size, we're going to make it so that it is a custom text size. All this stuff has to be figured out. This is the thing when you do programmatic views of any type of self size for content string, and we're going to pass in new text, and max width is going to be max width. Okay, we're almost done configuring. And now new label frame.size equal to text size. Okay, and new content frame.size equal to text size. New content frame size is also equal to text size. So basically just adjusting the size of the content to adjust for the label size. Label.frame. Label.frame is equal to new label frame. Right, so I'm taking that I'm resetting the frame. So I'm getting the frame here, whatever it was, and then I'm resetting it to the new frame, whatever I've calculated, right? And then my content view frame, right, is equal to the new content view. I should probably spell this right. Content view, content view. Okay. All right, so that is your setter. So again, think about your setters. if I have a video game, okay, this is what I always look at, right? I have lives and score. I can set the lives and score, but what if I want to update the scoreboard? That's your getter and setter, right? If I set the lives, I update the scoreboard at the same time and save the live score. That's what I'm doing here. I'm changing the label, text of the label, and updating my values, right? Just make sure I didn't type something wrong. Content view, new label frame is equal to label.frame. New content frame is a content view, not label content view. Content view.frame. And content view, I did it twice. Content view.frame.size. There we go. Okay, good. So that's this part. Okay, so that's, I think, does all the changes for this part. And now the cell class for the header. So the header, when we're going to make a new file. All right, so let me show you this one. So we've done the cell class for this one. Let me put this up on GitHub. So I'm going to go again. I'm going to go to here. I'm going to go to there. So just so you guys have what I have. I'm going to add a new repository up on Centennial. And it's going to be called lesson 11B, right? And create. And I'm going to say added content view cell. That's what it is. So that's what I did. So I'm going to go source control. I'm going to commit and push added content view cell, right? And then commit for files and push. And now you guys should have that. So if you didn't do it as fast as I did, go to GitHub and you can see what I got, right? Because mine worked. All right, cool. So that's this part. Now what I want to do is I want to add a new file, which is the header cell, right? Header cell.swift. All right, so header cell, right? Now this, what you want it to do is it's a subclass of content cell. So we can put in our own cell, our own content. So content cell, be careful, it changes this automatically, right? And you don't want that. You want to make sure that it's not doing this, right? Oops. So content cell is the name that we made, content cell, right? And then click next. And we create it, we add it in. We don't care about this right now, right? Here's our header cell, which is a subclass of content cell. Well, we just made content cell right here, right? Here's content cell, right? Why? Because we've already set up what the content is going to be there, and now we want a special case of content called header. That's what we're going to do, right? And that's why we're creating a special header cell. And how does this look? It looks like this. So we're going to override the both initializers and the default font. Okay, that's what's going to have to happen. So, all right, we do this. We say we're going to override, right? And the initializer is going to be the init frame, init frame, which means right away when we do this, we have to do the other. Remember I talked about this already, which we're going to fix this one. Oops. So this part gets added in, and we're also going to do the default font, override our class function called default font, because we want to change the font to be a heavier type. UI font. And it's going to return UI font preferred font with a headline style. Notice it's a headline style as opposed to a text style. So return UI font dot preferred fonts with a UI font style, UI font text style dot headline style. Right? That's what this part is. That's really wrong. But anyways. Okay, and up here, what's happening is it changes the background, right? So the background is 99881. So the background of the font, that's what this thing is, right? So you're going to see what the effect is. Again, we have to send this to super.init. So we're going to have to do our superclass super.init and then frame. That's the same. And this is super.init coder. We're passing values off to that, a decoder. Those are just default values. This one has to be satisfied. This one is unique, right? And then we're going to go label dot background color is equal to UI color. And this time our UI color is going to be red 0.9, 0.9, 0.81. So red 0.9, green 0.9, blue 3.8, and alpha 1.0. So just for those people who don't know, when it comes to color schemes like this, right? Alpha means transparency. How transparent? 1 means 100% opaque, and 0 means fully transparent, right? That's what alpha means. Okay. Okay, so that's the background color, and then the label dot text color now is going to be different, right? It's also going to be of UI color black, right? So UI, we can fool with these values later. UI color dot black, because that's the header cell in a nutshell. So the only thing we've done is, instead of redoing all that work, it's going to be like the content cell, but because we're going to have two cells inside of our cell, two cells. One is the header and one is the content, and it's going to be stuck inside that little row. So each row of our table is going to be unique. Okay. All right. So now that we added a header cell, it's a great place to put it up on GitHub. So I'm going to go to commit, and I'm going to go commit and push, and added header cell. Right. That's what we did. That should be up on GitHub. So if you weren't fast enough, you didn't see it, it's on GitHub. There we go. All right, and now that we've got this piece, we need to modify the the view controller.swift, and this is where a lot of the work is done. Here you have a bunch of three witches talking, right? That's what they're doing here, where they talk one to the other, and this is just sections. Notice that you have the header and the content, and it's in key value pairs, right? So what they've done is, inside the view controller.swift, you have a array called sections, right? Which is an array of arrays. Okay, it's an array of string arrays. Here's your array of string arrays, and the first string array is going to be the header. I'm not wrong, which is the first switch, and then the content, which is what she's going to say. And what she says is, hey, well, when will the three of us meet up later? So we'll put that in there. So when will we meet up later? Not exactly what it says, but who cares? And then we'll have another one. Let's just copy this a bunch of times, because I'm not going to type this all out. So first witch, second witch, third witch, and then first witch, second witch, third witch. So here's second witch, right? And they kind of do it in order, and this is the third witch. And when we'll meet up later, she says, when everything's okay. When everything's okay. Everything's okay. And the third witch says, that'll be just before sunset. Before dawn. Right? And something different, right? Okay, I'll say before sunset. Sunset. Before dawn, that's when witches are really cool. Where the dirt patch, and I guess I'll see you there. So where, that's what she says. So it's just like a communication between witches. Where, circle instead of the dirt patch. I'll see you guys there. Right? I'll see you there. There we go. All right, so this is some communication in these sections, and we have some stuff that they're going to say, as an example. And what we need to do now is, once we have that, we have to use something called this dequeuing method, all right? Which is interesting, because what they're going to do is it's going to look at the collection view, right, of the content cell, and for every identifier that has content, right, the content identifier, it's basically what it's going to do. It's going to register that collection view for that content. Whew. Right? Yeah. Lots of work, but you know, it's good to understand what the process is, just in case you want to try and do this on your own for some reason, right? So again, it's self collection view, and notice that there's a bunch of them. Like if I don't choose which one it is, it's content cell, for cell with reuse identifier, right? So collection cell, for cell. If you look through here, there's one that says for cell with reuse identifier. Right? You don't want to type this on your own if you don't want to, because it could be there could be finger typing issues, right? Because you know we're going to type, and of course I missed it somewhere. For cell. Okay. Collection view dot register. Content cell, contents cell dot self, and then we want to do for cell. Yeah, we're going to type this all. Oh yeah, for cell with reuse identifier, and the identifier is going to be contents. Okay, you do that. And then we're going to do this. At the end, we're going to say, okay, so this application has no navigation bar. What we need to do is basically create the inset. How many from the top? We have to space down, because remember, we're doing all the view manually, right? So we got to space down 20 points. So that's where it's going to draw its first cell, right? So var content insets, and what did I do wrong? I did something wrong. UI collection view not unwrapped. Was it supposed to be unwrapped? It was. Thank you very much. Over here, if I'm not wrong. Yes. And now we're going to have to do this content insets. So var content insets, where we're saying basically that the collection view, right, dot content insets. That's what that is. We're going to get the original one. And once we've got that, we're going to content insets dot top is equal to 20 points. That's what we're saying. So inset 20 points from the top. We have no navigation bar. And then collection view content inset is equal to content inset, which is basically we're sending it back. So instead of typing it, right, is equal to content inset. There we go. This sets up the spacing from the top. And what did I mess up here? I probably killed one of these things. Yep, I did. There we go. Okay, so that's that part. And are we almost done? We need a helper method called words in section, right? Yes. And just to show you this, I'm going to space down a bunch of times so you can see what I'm doing really quickly. I know I've lost you guys, but just bear with me while we do this. Words in section, where my section is an int. It's a helper method that we're creating, which is returning a string array. This does, and where we're letting our content that we're typing in is equal to the sections section, which is of contents. We're looking for the content area of the section. That's the content part. And we're also saying that the number of spaces inside is of type NS character sets. Right, dot white spaces and new lines, right? And we're saying that let words is equal to the actual words, the content components, content dot components, separated by spaces. So that's the spaces. So we're saying, hey, find any spaces that are white spaces and new lines, and that's how you're going to separate the words. inside of the thing that we're getting, and then we're returning them, return words. It's actually, you know, to me, a little helper function that allows you to read the array and split the array in different pieces. So we're going to get each of the words, and then we can spit them back out onto the cell. And if you don't do this, then you get some weird spacing issues. That's what happens. Okay, and yes, we haven't done actual population of the view. All right, so here's a method, number of sections. We're going to override this one because it's that special type. Override number of sections, right? Which is going to be sections.count, the number of sections that, how many times the witches talk. That's what we're returning. Okay, I know I'm going fast, but it's not for you to just necessarily type. It's for you to watch and just try to understand what I'm doing. All right, and then this part here is we're going to use the collection view number of items in this section based on the words in this section. Okay, so override collection view. Let's see if I can find this one. Number of items in section. Here it is. Ooh, I found that one. Number of items in section is let words is equal to our words in section. Words in section. We're going to pass in there the section, the actual section object, and then we're going to return the words dot count. How many words we got from the words in section. That's what this does. Okay. Crazy. I think it's crazy. A lot of work for a cell, right? But hey, you want to do it. This is your pattern, right? Okay, cool. And okay, we got this. We got the dequeuing method, and I think there's one more thing. Yeah. And this is in the cell for item at. You got to do this at the bottom for contents. So override. And we want to override the function collection view, and this is cell for item at. Collection view, cell for item at. We got to look for that too. Cell for item at. I think it's this one. See, collection view, by collection view, hit and display. Did I do that right? No, that's not the right one. That is incorrect, Tom. That's incorrect. Let's do that again. Collection view. It's not that one. It starts with collection view cell for item at. There is nothing else. Okay, so collection view. Collection view cell for item at. I'm sure if I start typing it, it'll give me a bunch of them. Not this one. I may have to type it because there's so many of them. Yep. Now, sometimes what happens is if you go cell for item at, and it also separates them, which is like this one. But that's not the one I want. Anyways, I'll just make it up. So I just don't need, I just need this part. So cell for item at. Cell for item at. Don't need that part. I need this part. And oh yeah, I did it twice. That's why I had a problem. Content view cell collection view, and that's the one. Do I want a collection view? I want a collection view, so I want to do one of these and move this over here. All right, collection view UI, cell for item at, cell for item at, index path. Okay, and then the code would be let words. Oh, what am I returning? I'm also returning UI collection view cell. Yeah, so returning UI collection view cell. And that's the completed Method signature. Okay, what's the other problem? Okay. Right. There we go. I didn't type it right. Okay, and then let words. Okay, here we go. Let words equal to words in section. We're using that again. And we're passing in the index path dot section, index path dot section. That's the number of words we're getting back. And then let the cell be equal to the collection view dot DQ reusable cell with string. And the string identifier is content. We've set that up before. And the index path is index path. That's what the cell is. And the cell max width. Max width. Why is that not working? Because I didn't cast it. Because I didn't cast it as content cell. Content cell. That's why it's not working, because it's just a default value, a default cell, which is not cool. Max width is equal to collection view bounds dot size dot width. Collection view bounds dot size dot width. And cell dot text is equal to, I believe, yeah, words, index path row, words, index path dot row. And then we're going to return, I believe, the cell. Yeah. All right, there we go. So that should take care of the collection view. We're linking the cell to that we made, and we're looking at the content, which we use that as dequeuable identifier, which we defined inside the cell. We're using that as the one we're going to put in there. And that's just for the content. There's been one more part of it for the header, which we're going to put in later. Okay, and now we should have something like this if we run it. So let's say run it, and let's see how it looks. And we should see something very similar to what it says there, but it's going to be our words, not their words. And this is not exactly what we want, because we have some problems, and it talks about these problems in the book, because it spaced it down 20 points, but it didn't space it in at all. There's no padding between the first part. Remember, we have to define all of our own constraints. We're doing all the constraints by hand here, right? We're almost done, I swear. So a little bit more typing. And if you look through, it talks about how you need to add, you have to add an additional flow control layout into the view controller, UI collection view delegate flow layout for this. So UI collection view delegate flow layout. No, collection view delegate UI collection view delegate flow layout. Okay, I'll just put it in by hand. No problem. No problem, Swift. I'll just type it by hand, and hopefully you'll like it. And then when we've done this, of course, we have to add in some additional, objects in here. So it says, this is the bottom. We're gonna keep on adding more view controls, right? So func collection view, and this one that we're looking for is collection view with the collection view layout is what we're looking for. Collection view layout. I'm using these drop downs because they're a little bit better for me. I can find the right one, but I can't, of course. I'm really unlucky. UI collection view. Okay, so fine. I'll start. I just keep typing until I find the right one. Collection view. Collection view. And then UI collection view. UI collection view. And then the layout. Now, maybe, no, of course. Collection view layout, which is of type UI collection view layout. UI collection view layouts. It's cool. Thank God we don't type that in. Size for item at index path. Size for item at index path. Index path, which is equal to NS index path. And what does this do? This starts fixing the problems that we saw with our layout, words in section, or passing in the index path dot section, and the let size is equal to the content cell size. Now you know why I didn't do this at the beginning, because you guys would have died in the beginning. You guys are dying now. For content string, which is words index path row, words index path dot row, and for max width as collection view bounds dot size dot width. Row and collection view bounds size dot width. And of course, return something which is of type size. All right, so what this does, when we go back to it, it gives us a bit of more spacing that we want if you ran it. And if I didn't type some weird thing. Yeah, of course it is. UI collection view dia. Where is that? It's here. UI collection view delegate flow layout. UI collection, too many else. View delegates, and that should do it. Which does this, spaces it out a little bit better, right? And it evenly spaces it out more than it did before. Guys, we can keep going with this, but the idea is, you can do it yourself. I'm going to keep recording. You don't have to stay. I know some of you have to go, but really what this is doing is it's going to put the header cell next, which is missing, and the stuff that we have. Now, remember, next week, before you guys go, your UI is due, right? So remember that I'm giving you 2% for you doing it, that lab number 4, which is due next week by end of class, so to speak. So please work with your partner on your assignment number 2 and get your UI done for me by next week, okay? Otherwise, I'll continue doing this. Huh? No, yeah, for the to-do list, okay? Yes. Do I have to what? No. As long as you let me know during class when that is, then I'm fine. Okay? Any other questions? Thanks, guys, for staying around. All right, and I'll just finish this off. All right, for you guys. All right, so. Yep.
This UI we have given for lab 02 or the to-do list.
Say that again.
You have given an assignment, right? To-do list assignment which we need to make.
Yes.
So we need a UI for that.
Yes.
By next week.
Yes. Okay. All right. Yeah. So we're going to keep adding stuff. Another collection view. And this is what happens, right, with this stuff. It's just not. Oh yeah, it's pretty crazy.
They're trying to do everything programmatically in this book.
But this is okay. I like it because what it does is it gives you the ability to really understand how things are created.
How it's done behind the scenes.
Yeah, that's why I like it, right? So, collection view layout. That's about right. Collection view. Did I override? No. Collection view. Layout. Collection view layout. I can't see everything. That's what it is, guys. All right, maybe it's that one. From layout? No, it's just layout. Yeah, undo. Oh, I was gonna have to type with my hands. All right, so it's collection view. Hi, take care. Take care. UI collection view. Just really long. Layout. Bye. Take care. Thank you for staying. Collection view layout. Bye. Take care. Thank you. Just UI. Section connection view layout. We're almost done, guys. And then size for item. Size for item at index path. At index path is index path. Oh, which we want to name index path, which is and this index path and this index path. And we're going to return from this one is CG size again. Is for the layout. And content cell dot size for content cell, which we're going to say that it is words index path row. And collection view dot bounds dot size dot width. Just redeclare the same thing. Yeah, I did. Of course. So, yeah, see how confusion goes? And then these in the method, which is over here, I'll be okay. I knew something was wrong when I was typing it. It was too much the same. Let layout equals to collection view. Collection view layouts, right? And then let flow is equal to collection view. No, layout is equal to layout as UI collection view flow layout. UI collection view flow layout. Collection view flow layout. And flow dot section inset is equal to UI edge insets is an edge list. Bye, take care. edge insets make, which is 10. This is just setting up the exact bounding box of the inset. And when we do that, and we run it, then we should see more of a separation in our layout, which is like this. Yay! Almost done. Great. And then the last part is really we want to know about the header class. So we're going to do this at the in the view load, because it doesn't know about the header class right now. We haven't set that up. So self dot collection view layout, collection view dot register, and then the cell class is header dot header cell dot header cell dot self and dot self. Sorry. And the string will be header, if I'm not wrong. Yeah, header. Let's register this part. And then we have this bottom part, which is another big part that goes down here for the header row, which looks like override func. And I'm not going to find it, chances are, but it's collection view. We're looking to view for supplementary element of kinds. Take care, guys. Did I get it? UI collection view force, no. No, no. I'm just going to have to type it again. I just can't see it because there's too many. Collection view, UI collection view. And then this one is view for supplementary element kind. Supplementary element of kind, which is a type string, at index path, Bye, take care. You too. UI collection reusable view. And what we're doing is if the kind is equal to UI collection view element kind, elements kind section header, then if that's the right one, then let cell equal to, this is a crazy cell, collection view dot BQ reusable cell supplementary of kind with reusable identifier header for index path. as a header cell. And cell.max width, cell.max width is equal to collection view bounds the size of width, collection view bounds dot max the size of width, size dot width, that'll be okay. And cell.text is equal to sections index path dot section and header. So looking for the header of the content now, not the content. And otherwise, we'll have a new statement called abort, which is like break. It kind of breaks up. Actually, it's like it aborts the whole program. All right, so that should do it. With one more exception, which is inside of our view did load. Load dot header reference size, header reference size is equal to CG size width is equal to 100 and height is equal to 25. And when I run it, now we should be done. It should show the, not that, definitely not show that. That is the error that I didn't want to have happen. I must have missed something, but you get the point. Okay, so let's put in, I'll do a commit. I'll say added support for spacing and header. Push. Now let us review. I must have done one of those funky things with the cell method. I think it happens just this last part, which is we did words in section. That was all working. We did the spacing stuff. We got to here and here. Okay, you did load and then this other stuff. Okay, so self. Self collection view register header cell dot self for supplementary. Take care, guys. Thank you.
Care, good luck.
Almost there.
Jerk, man.
I know. It's my exam. Take care.
You're gonna upload it to GitHub later, right?
I'm uploading it already.
Thank you. Thank you so much.
Take care. Yeah, this is the problem. And so self dot content view dot collection view. Sorry, collection view dot register and register for supplementary view of kind. This one. Register header dot self. Header cell dot self. Bye.
Bye.
Take care. UI collection element. UI collection. There. and header. I think that's what I did wrong. Let's try that out. That worked. Okay. And that really wraps up this section. This section's all around, for those people who are still watching, this section's all around trying to make everything space out properly and creating a header. They've just highlighted the header with different colors and the text of different colors. Of course, you can take that away, but it's really creating a customized cell programmatically. You can see the difficulties involved, the challenges, but I don't think it's that difficult. It's a good pattern. It's something that you would use if you're creating your own custom cells, and you can put other things in there like images, not just text. Okay, see you next week. Next week we'll have a lot of data, talk about data and persistence. We're going to skip that section of the book, and we're going to go right into that part because you need it for your assignment. Okay, otherwise that's it for me. I'll see you guys next week.